All right, here's the section 1.3 lesson video part 2. We're going to go ahead and finish off the 1.3 notes from the other day. All right, so here we're going to go through several examples of problems where we're going to be using more than one rule. So it's not just negative exponents, right? We could be using that product to a power rule. We can be using that quotient rule, right? We could be using all three rules in one problem. So the hope is that as we go through these examples, I'm going to go through every one of them together, and you're going to see the progression and how I go about trying to simplify these expressions. Right? You'll find, there's going to be an order in which you'd want to try to approach these type of problems on quizzes and tests. All right, so let's take a look at part E. So again, this lesson was about negative exponents and what negative exponents does to the base. So here's that -2 is an exponent, and all of this inside of parentheses is the base. Okay, so again, we can apply that rule, right, if you want to, and go ahead and take this base and flip it into the reciprocal. I'm going to go ahead and do that, right? So this whole base, that whole thing, is going to get flipped into the reciprocal. And again, for the reciprocal, that means that we're making a fraction. So we got a fraction bar, and all of that's in the base, all that's in the parentheses, is going to get flipped to the bottom of that fraction. All right, so again, we did that because of this negative exponent right out here, right outside the parentheses. All right, and we talked about with the previous lesson that, once you've applied that negative part of the exponent to the base and flip it into the reciprocal, you got to make sure you change that exponent to a positive exponent. Okay? All right, so from there, now we want to apply that power to a power rule. All right, where we have this 2 as an exponent outside the parentheses, and we are going to quote unquote distribute that through the parentheses. Okay, so when we do that, everything inside that parentheses is going to get that exponent of 2. So it's going to be 3 squared. That x to the -5th. Get that exponent of 2. And that y cubed gets that exponent of 2. Okay, all of that is in the denominator of that fraction bar. All right, so applying what we see, 3 squared is 9. Power to a power, we're going to multiply those. So -5 times 2 is -10. Power to a power, we're going to multiply 3 times 2 to get 6. Now we're not quite done with this problem because, we still have a negative exponent as part of our expression. So, again, it's just here with the x. Right here we have x to the -10 as an exponent. So we're going to apply that negative exponent rule one more time here at the end, where we are going to flip that base that has a negative exponent into the reciprocal. Now, because it's in the denominator already, that means when we flip it, it's actually going to get flipped to the numerator. So right next to the 1, we're going to have that x, and because we flipped into the reciprocal, that exponent is now going to become positive. The 9, there's no negative exponent next to the 9, so we're going to put the 9 still there. The y still stays in the denominator. Okay, so there's our final answer for part E. All right, let's take a look at part F. So again, we see this negative exponent right here outside the parentheses. Now, instead of doing what we did in the last problem and flipping this in the reciprocal, what I'm going to do is I'm going to take what's inside the parentheses and try to simplify that first, Notice the difference between part E and part F is that inside the parentheses for part F, there's a lot more going on. It looks pretty busy, pretty complicated, At least more so than with part E. So before I do anything with this negative exponent outside the parentheses, I want to take the time to go ahead and simplify what's inside that parentheses. So again, that means we are using our quotient rule, right? Because we see that fraction bar, it's got to be about the quotient rule. Okay, so let's go ahead and do that. So let's first do the coefficients. 2 over 4, that reduces down to 1/2. Here we have we have quotient rule. Okay, I'm dividing expressions with the same base. We keep the base and we subtract top minus bottom exponent. -3 minus a -7 is a +4. And we are using our quotient rule. Keeping the base, subtracting top minus bottom exponent. -3 minus a -7 gives us a +4. We do the same thing with the y's. We have y to the first divided by y to the fifth. Top minus bottom exponent gives me y to the -4. With the z's, z cubed divided by z to the -2. Quotient rule says keep the base, subtract top minus bottom exponent. 3 minus a -2 is a +5. Okay, so you see what I have left here inside the parentheses. A lot simpler, right? I don't have multiple places where I have x's, y's, and z's, right? I have them pretty much all in one spot. Okay. Now I'm going to go ahead and put that -2 exponent back in its place. All right, so now we're going to go ahead and apply the negative part of this negative exponent, which means we're going to take the base and flip it into the reciprocal. All right, so since the base is already a fraction, flipping it into reciprocal should make a little bit more sense, where we're just going to switch the places of the numerator and denominator. So this 2 that's in the denominator is going to go up into the numerator, and all this that's in the numerator, the 1, the x to the 4th, y to the -4th, and z to the 5th, is going to go to the denominator. And when I flip that base into the reciprocal, this -2 as an exponent is going to change to a +2. Okay, now before I go ahead and take this 2 as an exponent and distribute it through the parentheses, I'm going to go ahead and take this negative exponent and apply its influence on this expression. Remember, we said anything with a negative exponent is going to get flipped into the reciprocal. So just that y is going to get flipped up where the 2 is in the numerator, but everything else is going to stay in the denominator. All right, so now I'm going to go ahead and apply that 2 to everything that's inside the parentheses. So that 2, I'm going to get an exponent of 2, that y to the 4th, exponent of 2, that 1, that x to the 4th, and that exponent of 2, and that z to the 5th gets an exponent of 2. And so let's go ahead and simplify all of that. So I got a 4 y to the 8th over 1 x to the 8th, and then y to the 10th. All right, so let's go ahead and see what you could do with g, h, and I. Trying to simplify those expressions down using any of the 3 exponent rules or properties that we talked about. And then when you're done, go ahead and continue the video to check your answers. All right, so let's take a look at part G. Again, here we don't have the parentheses, so we don't have to worry about distributing anything. We can go ahead and just apply our quotient rule. And I showed you here with my work. Again, we're going to keep the base of a. I'm going to subtract top minus the bottom exponent. So it gets me a to the 3rd. With the b's, keep the b, keep the base, subtract top minus bottom exponent. Got b to the 40th. And then for the c's, keep the base, subtract top minus bottom exponent. Okay, remember, when there's no exponent that you see, you assume it to be 1. And so I get c to the 14th. For part H, okay, we talked about how if you have a zero exponent, right? Whatever that zero exponent is attached to in terms of a base, that whole thing goes to just 1. And that's what happened with h. Because there's a zero exponent attached to all of this stuff right here, no need to do anything else other than write down the number 1. For part I, again, just like what I did with part B, I'm going to go ahead, I went ahead and simplified what was inside the parentheses. All right, so I got the x's, top minus bottom exponent gave me x to the -9. Now you notice the y's, there's only one y's there in the denominator, so that's why it's just y cubed, nothing changed there. The z's I changed, right, because I got z in the top, z in the bottom. Top minus bottom exponent is -3 minus the -2 gives me -1. Okay, so now we're not done yet because I still didn't do anything with this 3 as an exponent. So I'm going to go ahead and distribute that through the parentheses. Oh, and actually before I do that, let me go ahead and take care of these negative exponents. Because the x and the z both have negative exponents, they're going to get flipped into the denominator. Now again, the y doesn't have a negative exponent, so it's not going to flip. The z and the x will flip. They were up top, but now they're going to be in the bottom. And when we flip them, the exponent changes to a positive exponent. Okay, so that takes care of the negatives, and I suggest you try to take care of the negatives as soon as possible. All right, so now let's go ahead and use that 3 as an exponent outside, so I'm going to distribute to the 2 and to everything that's in the denominator. Oop. So I have 8x to the 27th, y to the 9th, and then the z cubed. Okay, so I'm going to finish off with just one of these last 3 problems here. So I'm going to do part K. All right, so again, we got to be careful on how we use those rules. Okay, so we talked about a bunch of different rules so far with this first unit. All right, so you want to make sure that you are using the rules properly. So let's take a look at the numerator, because we see a parentheses and this zero exponent attached to that parentheses. Again, recognizing that and what a zero exponent does to the base, it changes all of that to a 1. Right. Now that zero exponent is not attached to whatever's in the denominator, so the whole thing doesn't go to 1, just what's in the numerator. Okay, so I'm just going to go ahead and rewrite what's in the denominator. And again, that zero exponent only affected stuff that was in the numerator. All right, so we use that rule. So again, no need of, can't do quotient rule, don't need to do that. Just use that rule dealing with zero exponents. All right, so you can see what we have left is a lot simpler to look at. So now we're looking at these negative exponents. So those negative exponents says we got to flip it into the reciprocal. They are already in the denominator. So when we flip that into the reciprocal, that means it's going up into the numerator. So right next to the 1 goes the x to the 3rd. Again, when you flip it, make sure you change those exponents to positive. This y to the -5th power is going to get flipped to the reciprocal, so it goes from denominator to the numerator. Exponent changes to a positive exponent. This z does not have a negative exponent, so it's not going to flip anywhere. It's going to stay exactly where it is in the denominator. Okay. All right, so that's it for section 1.3, part 2 lesson video. Go ahead and finish up the rest of the 1.3 homework. If you have any questions, make sure you ask.